Ladies and gentlemen, this is Joe's Classic Video Games back with a guitar amp repair video for you this evening. We usually do arcade game, pinball machine, and jukebox repair videos, but lately, on the weekends, I've been doing this little segment called Amateur Repair Time, where we try to just fix other stuff and see if just messing around with it, we can get it to work. So what we're messing with tonight is this old crate amplifier here. It doesn't work right. So I'm going to see if I can fix it. We'll take it apart and see if we can figure out what the issue is. And then that'll be that. So if you're into arcade games, pinball machines, and jukeboxes, and that's the only reason you like our channel, that's understandable. We will be back Tuesday with a pinball machine video, so we'll see you Tuesday. But if not, hang on. So this, I mean, if you'd rather, if you just enjoy the content, hang around a little bit. This crate amplifier I picked up. I actually bought it online and had it mailed to me, and I bought it from a thrift store, so it wasn't guaranteed or anything like that. It actually works, but the chorus doesn't work, which is the only reason that I bought it, really. I've got this cool old school PV down there with nice reverb on it. This crate amp, I like the ones that are made in USA or made in Mexico or something interesting, you know, the ones that are a little older from the 80s and the 90s. This crate amp is also made in the USA, and it's got even nicer reverb on it, I think, but the chorus doesn't work at all. So we're going to attempt to take it apart and see what we can get going. So let me turn it on, and I'll just show you what it's doing. I've got a guitar plugged into it just so you can hear what it's doing and what the chorus is doing, which is really strange. All right, so see if we can get some sound out of it. So it's got a nice reverb, so we'll turn that up. So the reverb on it is great. Okay, and we're on the clean channel. Okay. So you can turn it on this overdrive channel. Okay, and it's got this shape control here too that's really interesting. I don't know much about. Okay, so let's go back to the clean channel. We'll turn the reverb down. And I actually have the chorus on right now. If I turn that off, so I'll hit a note and then turn it on. It's kind of there, right? But watch what happens when I turn up the rate or the depth. All right, so let me turn up the rate. So I don't hear any difference in the rate that it's doing anything. And the depth doesn't really seem to do anything either. So this is on 0. This is on 6. You know, it's not doing anything. And it starts clipping. So if we turn it off, so that's not working properly. I'm not completely sure how deep that chorus is supposed to sound, but it did sound like we've heard something resembling chorus there for a minute, but it's certainly not working right. And we shouldn't be getting all that clipping, I don't believe. So this is a Crate GX30M. And just so I'm clear, none of these are worth anything. So this is, I hate whenever people are making videos where they're bragging about, oh, look, I got this was worth $3,000. This amp might be worth $100 if it was in nice shape, you know, so it's not worth a bunch of money. But this is the type of stuff I like working on, stuff that's kind of been discarded. We're going to put some grill cloth on it too. But stuff that's kind of been discarded, like, oh, that old Crate amp, you know, it's got problems. It's not working right. Let me get something nicer. So I like finding stuff like that. That's decent quality in my opinion, but kind of lower end stuff. That's my favorite, you know. So I've got this guitar we're playing here is just an old K from the 90s. That's just a cheapo copy of like a Gibson, right? But that's my kind of stuff. I might rather have it than the Gibson. But so that's what it's doing. Let me show you the schematic. There is actually a schematic of this bad boy. And we'll see if we can figure out what might be one of the problems. And it's a Crate GX30M. All right, folks, so here is the schematic. Made by SLM Electronics, is that it? So this is from them somehow. They must have gave away the schematics back in the day. That's pretty cool. On the arcade games and the pinball machines, they do that. Well, they used to. You don't get schematics with the new arcade games. You still do with the pinball machines, though, I believe. Okay, so this is the amp. Now, I don't know much about guitar amps, but I've been looking this over, and we may be able to figure out what's wrong with it just by thinking about it. So the reverb works, the EQ works, the overdrive works, and the clean channel works. The only thing that doesn't work is the chorus. So that means all we have to do is eliminate all of the stuff that we know works. So here is the speaker. Or maybe there's the speaker, whatever. The speaker is in this area, right? And so all of this comes from up here, and it's coming from this area they call the power amp. And so does that work? Yeah, we know that works because we can hear that everything's amplified. Like we're getting, it works fine, just the chorus doesn't work. So all of this works, therefore we don't have to mess with any of that. Okay, and then just before you get to that, if you look, see how this is the speaker, blah, 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 blah. The input to all of this is this one line here, which they have labeled as TP7, test point 7. And that is a NE5522. Is that correct? I think it's 5522. Obviously, I've got this on the computer too, where I can read it a little better than this printout. But it's an op amp. And if you notice on the op amp, it says positive 15 volt C and then negative 15 volt C. Now, the reason they're saying C is because down here in the power supply section, there are actually 4 different 15 volts. 15 volt A, B, C, and D. And then negative A, negative B, negative C, and negative D. And all of those are derived from a positive 20 and a negative 20. So what they're showing you there is that that particular op amp runs off of the C rail. So plus 15 volt C, negative 15 volt C. If you look over here, it's off of the 20 volt. All right. So we know all of this is working. So let's start over here at the other end of the schematic. It says foot switch. You can plug up a switch that literally, just as they say, you use your foot on. And with that switch, you can move between the chorus being on or off, out or in, and the channel switching, out or in. Okay. Now, this is hard to see, but you can see it on the computer. That is an A. So this signal here is A, and this signal here is B. So I'll show you why that matters here in a minute. The guitar plugs in right here. And one part of the jack goes to ground, directly to ground, and the other part is this signal. And so we get here, and on these two diodes, we have 15 volt A and negative 15A. We go into an op amp, 15 volt A, negative 15 volt A, blah, 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 blah. It runs through a bunch of stuff, capacitors. Here is our EQ section. So we've got mid, low, and high. These little arrows on the jagged line are showing you a potentiometer. Right, here's another one, level. Okay, so this is just how they equalize that signal. And then here you have, it says A. Well, that's telling you that that's the switch that's mirrored up here with the foot switch. And so A is the channel switch, right? This will make more sense as we go along. Yeah. Okay, we get up to this preamp, plus 15 volt A, minus 15 volt A, right? And so the signal, you can see it's flowing from the jack through here. We'll ignore this for now. Through here, right? And then it all kind of comes together here. So you've got it goes through the op amp. It also goes through a resistor. It also goes through a cap. And all of those three lines, where test point 6 is, goes through a little resistor, go over here into our op amp, and then into our final amplification stage. So we know that works, right? So what this is showing you is how the clean signal is created. So when it's clean, that's what you've got going on. And it's turned off if this switch isn't in the right direction, right? So you have this signal that ends up right here. If the switch goes in, I guess that shorts it to ground, or it makes both of the inputs to this ground. And so none of that signal gets through. So if that were to happen, the signal would still be here, I suppose. But it comes in, and it also connects this way. It goes through this one capacitor here, a 10 microfarad, 16 volt. And it comes up here to, yeah, right? It goes through these two resistors. Now this also says A. So what's happening is if you hit that switch, it'll switch between either the clean channel or the overdrive channel. Okay? So let's say that we've got overdrive on. Well, then this is connected, and this is grounded. So your signal from the jack will come in this way and go through the overdrive section. Now remember, our clean signal all worked fine, and our overdrive signal all worked fine. So let's say that the signal comes this way. It gets over here to this op amp, and it's also running on the A rail. right? It goes through, there's some diodes here and resistors and capacitors. Here is the gain knob for overdrive. All right. Here is yet a third leg of the switch. That must be a heck of a switch. So it turns this on. We go through another stage of the op amp. There's another test point. And it goes on and on and on. Here's the shape control. And here's the level control. So you've got gain, shape, and level. And the signal goes through and blah, blah, blah. And it's processing it, making it sound however it does. Now keep in mind, folks, this is amateur repair time. So I'm just giving you the layman's explanation. Someone who really knew what they were doing could explain this in better detail to you. But this is basically how it's working. We're trying to figure out what's going on with our chorus. All right, we're going to get there. We're going to figure it out. And so that signal that has now been routed through the overdrive so that it can go through a different set of op amps, different diodes involved, these switches turned on, right? Different set of controls. That signal is now coming out right here, and it circles back around through that resistor, and bam, it ends up right where the clean signal would have ended up. Now, the clean signal would have been right here. Our overdrive signal is right there. But if you're on clean, these, this and this are not connected, right? So you're not getting a signal into this area because it's cut off right here. So the overdrive would have nothing on it. If the overdrive is on, then this isn't connected. So right here, you've got either the overdrive or you've got the clean signal. So all of this seems to be working fine. Okay, so then here we have the reverb. The overdriven signal or the clean signal will be right here and then come out right here at test point 6. And then, of course, it also is going through the resistor and through the cap. All right, so our signal will be present right here. So while it's running this way, it also can run this way, right? It will be at the same time. So it goes through a cap and into this op amp. And they've got it arranged a little differently. And then it goes over to a speaker connection, it's like an RCA jack, an audio connector, into the reverb tank. So there's literally a tank on the side of the cabinet with springs and things in it, I suppose. And they shoot the signal down through there. And it makes weird noises. And that's how you get your reverb sound. And so it comes back out this side, runs through some more processing stuff, caps and resistors. You know, it's all caps and resistors, people. I mean, caps and resistors. And then it goes into this op amp, which would be a transistor. Caps, resistors, and transistors. It runs through this, and look at it. It's running off of the B rail. B. Right? And then it gets over here to the reverb knob. Now, if you have that on 0, it's going to pass none of that weird signal that it just created by running through the springs. This is the signal, right? The reverb signal will just stop right there and you'll never hear it. But if you turn the knob, you add it, you turn it up a little bit, and it mixes in, bam, right here where both of our signals have just showed up, either the overdrive or the clean. So that reverb is working as well. So we know that the B power rail and the A power rail are working fine because all of that stuff works just fine. Okay, so what about the chorus? That's the only thing we got left. Well, when the clean signal or the overdriven signal gets through this op amp to right here, it'll run through the reverb, but then you got this line. So it comes this way. And through this resistor, enters into our chorus section. Right? Now notice there's no switch to turn that off, at least right here, right? So your signal from the guitar is going to be right here. Runs through these resistors and caps, and they're using this, I guess, to just shape tone or something, or amplify it or lower it. And then it runs into this, I always get this wrong, MN 3007 chip. So that chip is it's what do they call it? A BBD chip. It's a bucket brigade device. And the purpose of that, I've looked this up. I don't know this off the top of my head. I looked this up. The purpose of that is to provide a delay to the input. So you run a signal in, and then it's going to delay that signal before it sends it out. Okay. Now, connected to the MN3007 chip is this MN3101 chip. And you can see that it has 3 connections to that chip. CP1, which is the clock 1, CP2, which is the clock 2, which is the inverse of clock 1. They're just, I believe that's correct. It's like the upside down version. And then VGG, which is a voltage that this chip creates to control this chip. Okay. Now, if we keep looking, notice that I don't know many details about any of this stuff. All I'm doing is just looking for logical things, right? I'm just trying to logically figure out what in the world's going on here. Now, this chip, if you look, has this stuff all connected to it, and only that stuff. See how all of this doesn't touch anything else? All of this just goes to here. So there is a path here, right? So it starts over here with ground. And up here with 15 volts, or is that negative 15? It's positive 15. All right. So we have look, we've got them on these op amps too. But look, we've got a D here. Plus 15D, minus 15D. So this is our D rail. So you've got 2 more op amps. I'm calling them op amps. I suppose that's what they are. NE55, does that say 32? Is that what they are? NE5532, I guess they all are. They're probably all the same. This one says rate. That's the rate pot on the chorus. And then this one says depth, the depth pot on the chorus. Now, if you watched, whenever we turned up the chorus, I got it to a point where it was going duck, 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 and you were getting like a popping out of the speaker. But you weren't getting the chorus effect. I thought I heard it there for a second, but it went away. But when you turn I think it was the depth one. When you turn one of them, eventually you do get like this weird popping, cracking noise in the speaker. So that tells me this stuff might be working. So it could be that this is working and we've got a problem here or something. But this is the output, which is where that sound would come from. Like, if this is doing crazy stuff, you wouldn't hear it. There'd be no way to hear it. It has to come out of the output, right? So the way it looks like it's supposed to work is these shape the signal or whatever, or shape something, because there's no signal over here. They just shape a voltage, I guess, or a clock. And they send it over here into this chip. So this, if you look, has 3 inputs. OX1, OX2, and OX3. And so you see 1, 2, and 3 are all connected to the same input, but to get to 2, it has to run through a resistor and a diode, and to get to 3, it has to run through a cap. So you've got these 3 that are feeding this chip, telling it what to do. And you have a ground wire, ground connection, and then you have this voltage, which is negative 13. So the negative 13 is created right here. They take the negative 20, run it through a resistor, and then use a Zener diode to make it happen. I've never understood how these work, but they do work. So it says this is a 15 volt, so I would think that would be 15 volts, but maybe the cap changes it or something. I don't know. So this chip needs -13 and ground to run, and then it needs this stuff to tell these three inputs a certain voltage or pulse or whatever. And then it uses that to create the voltage for this chip and the two clock signals for this chip. Okay, so this chip takes the input that, remember, is coming from right over here, our clean signal or our overdriven signal that's running through the reverb. And it runs in, and then it outputs it by delaying it. All right, so then it delays it, and then it runs through these resistors, right? And then, bam, it runs through this, which is a switch. This is the B switch. Again, that if you hook it up on the foot switch is the chorus switch, right? So that is the switch that turns the chorus on and off. And then where does it go after that? It just comes right over here where the reverb comes out, where the clean and the overdriven signal comes out. So if this switch is on, you're going to get, and this switch is off, you're going to get a clean sound right there. You're also going to get a reverberated sound right there. And you're going to get a chorused sound right there. So you can have clean, reverb, and chorus on at the same time, or overdrive, reverb, and chorus on at the same time. And reverb can be turned off by just turning the knob down, and chorus can be turned off by hitting the switch. It's pretty cool how this works, how they have these two chips that like talk to each other. Okay, so there's that. So what is our problem? Well, I'm thinking it may be this D rail. If you think about that, if that was bad, if A, B, and C were working but D was out, then these wouldn't work right, and it would screw all this up. This one's ran off of the C rail as well. So we need to go in and test some voltages and just figure it out. So the first thing I'm going to do is test these. Now, but look over here too. This is interesting. They have a chart. It's a little hard to read on this printed version. The overdriven channel, switch 1 in overdrive, input signal 50 millivolts, peak to peak at 1 kilohertz, shape, gain, and level at 10, EQs at 5. Okay, so when you go to these test points, it's showing you what the AC voltage should be and what the waveform should be. So if we can't figure it out with the voltage, we might be able to use a scope on it. I'm not good with the scope, but I can kind of use it. And then if it's the clean channel, blah, 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 it's showing you what the waveform should look like. So where that might be useful on this one is to see if we have these clock signals. If this is screwed up, we won't have these clock signals. This chip won't be getting its clock signal, and so it won't know how to act. So it would get the input, but it might not give an output. Now, we could have, too, a situation where, like, this resistor's burn up or something, and the signal's never getting to it. But to be honest with you, that's not that common because there's not a lot going through this. You know, we know our signal's good here because you can hear it. This is where the clean channel and the overdrive channel meet, right? So if that signal's good, why would it burn up this resistor? Unless this chip shorted or something, but I mean, they're not going to do that. These caps are non-polarized, so they're going to be little ceramic caps or something, or little glass caps or something. Usually they're not going to short, but maybe. So I think it's about time to take the thing apart and see what we're looking at. All right, so I took it apart. Not hard. There's 4 screws on the top that hold the chassis in, and then there's 4 screws that hold the speaker board in. It's solid state, and so I think I'm fine with running it without the speaker plugged in. So we've got it turned on. And the first thing I'm going to check is the negative 13 volts. So this R71 has negative 20 on one side and negative 13 on the other side. So we're reading negative 21.1 and negative 14.7. So that voltage is there. It's a little high, but it's still there. So, but that sucks. I was hoping it would be missing. I need to figure out where I can test for the plus 15 and the minus 15 D, plus 15D and minus 15D. It's not quite as well laid out or as well marked as it is on the schematics. So this is the overdrive section. There's the jack coming in. This is the clean section with the EQ and everything. This is the power amp here. The red one there is the reverb. And then that switch and these two potentiometers. This is all the chorus. This is the part that isn't working. Okay, so I measured the voltage, and all of the op amps are running on like 18 volts, and the voltage is there, and none of the voltage is missing. So it's supposed to be 15 volts and negative 15, but it's like 18 and negative 18. And the reason for that is probably because the line voltage coming from the wall is higher than it is supposed to be. On the back of the amp, it says 115 volts, but my voltage here is like 126 or something like that. So they're all running high, which is just a problem you run into with any kind of vintage electronics. Since it's not regulated, it just, the voltage is just higher because it's coming out of the wall like that, and it's just running through a transformer. So if we're looking at this section of the chorus, that we've got those 2 IC chips that are running on 13 volts is what they designed it for. Okay, so the 13 volt section is running at a little over 15. So one of the chips, there is a clock generator. So this is what's manipulated with the pots and all of that. And it sends out a clock signal and an inverse of that clock signal over to that other chip, right? So it says absolute maximum ratings, supply voltage, 18 volts, negative 18 volts. So it can handle negative 18. Ours is at negative 15. It's on the schematic, it's spec'd at negative 13. So this is the 3007, which is just a chip. It's a delay chip. That's what they're using to make this chorus effect. And the voltage for it that they have spec'd at negative 13 volts, its absolute maximum ratings is it can handle negative 18 volts. So since our negative 13 has drifted and now it's negative 15, it looks like we're still within reason. So I don't think that's the problem. So this section basically creates a clock signal with this chip. It uses OX1, OX2, and OX3 as inputs on this chip to create a clock signal, and then the reverse of the clock signal, the inverse of the clock signal. That is used to shape the speed of the chorus that this chip creates. These schematics are really nice. It shows you right here, test point 9 is that clock line. So they want you to check that clock line. So 3101, if we check pin 4. Now, I never do this, but I actually had to get my scope out, one of my scopes out. You know, I don't like scopes because the whole thing is I like being able to fix it with like a screwdriver. I don't like having to use extra tools and stuff, and it takes forever to even learn how a scope works and blah, blah, blah. They're really good instruments and really good tools, but I like fixing things as simply as possible. But in this instance, there's no simple way to fix it without using a scope. So if I check out pin 4, let's see what we get here. So this is test point 9. That's a pretty square wave. Here, I'll do it again. If you look down at the bottom, see it says channel 1, 5 volts per division. And that is jumping 3 divisions. So that's 15 volts, which is what everything's pretty much running on. Now, if you look over there on the right, it says channel 1 peak to peak, 17 volts. So all of this is running on like 17 volts. But that is a clock signal. See it? And if you look, this is the overdrive channel. There's our clock signal, and it does look right. And then this is if it's clean. There's our waveform, and it looks correct. AC voltage, it's saying 13. Is that what it's saying? Maybe I can zoom. Can I zoom? Yeah, there we go. It's saying 13 volts peak to peak, but we're getting 17 peak to peak because of what we talked about a minute ago. DC voltage, -5 volts DC. Okay, so the number 10 waveform looks correct. I mean, the number 9 waveform looks correct. We are getting a clock signal there. So all that means, though, is that this chip is working. We kind of knew that because whenever you turn this, we were getting that changing. All right. Yeah, maybe I could turn the knobs and see if that changes anything. Boy, you'll love this. Oh, I can't do it. I don't have 3 hands. Let me get the tripod. All right, that's the best I can get with my tripod. Check this out. You're going to love this. I'm going to check it again, and we're going to adjust the 2 knobs. One is depth, and one is rate. Depth and rate. Let's see which one's which. If I can not get electrocuted. I would like not getting, okay, I see. Depth and rate. Okay, so I'm going to probe that pin again, and then we're going to turn the knob so you can watch what happens. So see how now you can actually see the waveform on there because I've been messing with these knobs. So this is the depth one. This is all the way down. As you turn it up, it goes out, and then at some point it comes back in. Okay? So that's the depth one. And see how it's doing that on its own? I'm not turning the knob right now. I have it cranked up pretty good, and that's what it does. So if I turn it farther, it goes farther out. So this is the time between triggers, basically. Right? So the depth is down lower now. So it's not going out as far now because the depth is down. So that's actually a good name for it, right? Okay, so that's at about 4. All right, now watch what happens when I turn the rate up. Look at that. So that's what we were seeing earlier. We were seeing that. because we had the rate and the depth turned way up. So that's the clock signal going into the other chip. I gotta say, that looks to me like it's working fine. I mean, seems right, doesn't it? So let's see if the other clock line appears to be the inverse of that. I could hook up both probes, but we'll just try to eyeball it. So let's see if this looks like anything similar. Yep, it does. Okay, so I think that chip's working, and I think all that stuff before that chip is working. But I've got a test point 10 in that area too. I'll check it just to make sure it looks right according to this waveform. But it looks good to me. I think the one chip, the clock chip, is working. It's drawing a jagged line, man. So now peak to peak is 120 millivolt. And it's telling me that, yeah, it should be a jagged line. Okay, so I have the speaker unplugged, and the pin that goes into that chorus chip is pin 3. So I have the probe on pin 3. If you look, it says 600 millivolts. That's just where it's at whenever you're not doing anything. I have the guitar plugged into the amp. I've got the speaker unplugged. I've got it on overdrive, and I've got it turned up a little bit. So if I just pluck a string, pretty good. See how the voltage goes up and see how the line ripples? Right? So now we're just sitting here. See how the voltage goes up? So that's the input to that chip, to the chorus chip. So here's the output to the chorus chip. So see the 600? Now I'm going to pluck it again. Nothing. Nothing. So I'm going to turn up the chorus, both of the rate and the depth way up, and see if it changes anything. Nothing. So I think that chip's bad. I get nothing out of it, and we're getting the clock signal into it. What do you think? All right, so looking at the data sheet, this negative 13, on mine, I just checked it, it's negative 14.6. That's not crazy at all. If you look at the spec sheet, it says that it's supposed to be running at negative 15 anyway. So, you know, it's right in spec. They may have even written negative 13 knowing, well, I don't know, whatever. Okay, and then there is also this line, this VGG. So that line needs to be 1 volt less, or 1 volt more than this one. So if this is negative 13, it would want that to be negative 12. And it's part of what it uses to make this delay work. It's a BBD, which is a bucket brigade device. So it's basically used to make a delay of a certain time depending on the clock signals. So anyway, so this should be negative 13, this should be negative 12. On mine, this is negative 14.6, this is negative 13.6, which again, if you look at the schematics, the data sheet, that's exactly what it wants. So this chip is getting everything it wants. It's getting 2 nice clock signals, it's getting its voltage and the ground, it's getting the VGG signal, and it's getting an input, but you're getting no output. So it's got to be this damn chip. I'm going to say 60-70% chance it's that chip. Reading online, people are acting like they don't go bad that often, though. But dealing with, like, old arcade games and stuff, arcade game PCBs, chips that do math fail a lot. Now, counters go bad all the time. And it sure sounds like a counter to me. It's similar, right? This chip here actually creates that voltage. It's just part of it. This is a really cool chip. This is a cool setup. I've never seen this, but it's really neat. So you've got your ground and you've got your supply voltage. It uses that supply voltage and it makes this an output because it's outputting the 2 clocks and the VGG signal that these need, that a BBD needs. So this is designed specifically to do this, and it takes this voltage and it makes this voltage 14/15 of this voltage. So whatever its supply voltage is, it will make that output voltage 14/15 because it knows that that other chip needs that. And it's doing that, and it's got the clock and the inverse of the clock. It's doing that to set up that bucket brigade thing happening in the other chip. So it's just really cool design, whoever came up with this. So yeah, so I got to try to order one of those. They say there's a whole bunch of fake ones. And they say that they're also in all of the little toys that do reverb, and anything that does reverb might have this in it. So like a little microphone that you talk into and it echoes your voice and stuff, it's probably got this chip. I don't have anything like that though that I know of. So I think I'm just gonna have to order one. All right, folks. So here is the reverb tank. I think it has springs and stuff in it, and I think we're looking at one right now. That little spot there, I think it's a spring. Maybe not. So we'll have to wait for that part. I've also got this little cheapo Dan Electro amp, but it doesn't have reverb or anything on it. I was considering taking it apart. Look, you're not supposed to be a part swapper, so I'll just wait on the part. But here we sit. I'd like to get this one going, so I'll have chorus. I don't want to add a bunch of pedals in. I like it when it's just on the amp. I feel more like I'm, like I'm legit then. And I've got some speaker grill cloth coming. Our speaker grill has seen better days. So I got some that's like one of the Fender styles that's kind of like a red. Well, I better not do that, mess up my PV one. That's got lines in it that's more like a red. And I think it'll look good. And we'll try to put the logo on it and everything and put it back with just nice new speaker cloth. If we can get this chorus fixed. So leave your comments below. Let me know what you think. You saw me go all the way through that circuit. Kind of. I know you couldn't see the scope too good because of the angle of the camera, but like I said, I'm not very good with the scope. You saw what happened. So this is my logic here. I found before that when I ask people questions online about stuff like this, I never get a straight answer. My buddy Matt that comes in the store sometimes, there's 2 Matts, by the way, but one of the Matts, he's an engineer. He usually kind of knows what I'm talking about if I ask him. I didn't ask him about this yet, though. Maybe I'll send him that video of the clock signals. I did see that the peak-to-peak on that was a little higher than the 13, but I think they were just saying 13 because that was the input voltage. So I don't know. It should be all right with the clock signal being higher peak-to-peak. But so we're waiting on the chip. When we get it, we'll pop it in, and then that'll be that. So let me know what you think so far down in the comments, and we'll see you on the next one. Hey, don't forget to check out my brother Donnie. On Tuesdays, we usually on this channel do arcade game, pinball machine, and jukebox videos, and on Fridays, my brother Donnie does videos on old vehicles, old buildings, and he's got a farm. So go check him out. I'm over there with him on his channel usually. And then on Sundays, usually we do just, messing around videos like this that we call amateur repair time. Hopefully this video proved that I'm an amateur, but I think I've got a pretty good grasp of how it's at least trying to work. And hopefully that chip will get us fixed up. We'll find out next week. Now, I do still have my Majestic radio here that I'm working on as well. I'm also waiting on parts on it. So you'll just have to wait on that too. But I haven't abandoned anything. We're still working on it. Oh, I was talking about how I had several scopes. Look at this big, bad sucker here. I didn't have the guts to try to use it. We'll do another video on it one of these days, but that really needs to be... I hate to even plug it in, you know. That really needs to be gone through before you try to use it on anything. And I was considering using my Variac to plug up the amp with the voltage turned down just to make sure that that 13 being 14.6 wasn't a problem, but I don't think that's it. So, all right, folks, so there you go. We will see you on the next video. Hope you got something out of it. Sorry so long. You know me, I don't like making long-winded videos. But I hope you enjoyed it. We'll see you next week. Hopefully we'll be able to finish it up. I'm waiting on the mailman.